Alright, this is my tutorial on integer exponents. I should have introduced some of this stuff before, but let's go ahead and get started. Alright, first off, let's review. Here we have 5 raised to the power of 3, or people say 5 cubed, or people say 5 to the power of 3. The 5 is called the base. And what does the base represent? Well, I'll tell you in a second. The 3 is the exponent. And that exponent is a little 3 it's called a superscript above the base. Now, together they make up what is called a power. A power is comprised of a base and an exponent. And so we really don't, even though we call them exponents, we're really talking about powers. All right, so what is a base? A base, it tells you the number that is used as a factor. And the word factor means multiply. Now in earlier grades, probably in 5th grade, they told you guys, hey, the base is the number that is multiplied by itself. Now you can say that to yourself, but the more adult way, higher learning definition is the number that is used as a factor. And remember, again, factor means multiply. Now the exponent. What is the exponent? Well, the exponent tells you the number of times that the base is used as a factor. And again, you see that word factor, which means multiply. And in lower grades, they told you how many times you multiply the number by itself. But again, higher level thinking tells you that the exponent is the number that represents the number of times that the base is used as a factor. Okay, so let's go ahead and get started. All right, now first, very important in my class, whenever you're doing powers, you always want to identify the base. Again, you want to ask yourself, what is the number that is used as a factor? Next thing you need to do is identify the exponent. Okay? And to identify the exponent, you got to write down how many times is the base used as a factor. And I forgot the question mark, but that's going to tell you, it's going to lead you to get the correct simplified expressions. All right, so let's go ahead and get started here. The directions are to write this in exponential form. We have 8 times 8 times 8 times 8 times 8. And again, when you're working with powers, you want to ask yourself, what is the base? So here, what is the base? What is the number that is used as a factor? Well, that number is 8. 8 is used as a factor. The next thing you want to ask yourself is how many times is 8 used as a factor? Well, you count 1, 2, 3, 4, 5. It's used 5 times as a factor, and so your exponent is going to be 5. And so 8 times 8 times 8 times 8 times 8 in exponential form is 8 raised to the power of 5, or 8 to the 5th power. How about here? We have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And again, to do these problems, you want to ask yourself, what is the base? What number is used as a factor? Well, here we have negative 2 that is used as a factor. Now, a lot of people write the negative 2 this way, but that is not correct. The base is, when the base is negative, in other words, it has to be in parentheses. When the base is negative, it has to be in parentheses. Here, the number that's being used as a factor, which is negative 2, so you must put parentheses around the negative 2. That is very, 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 very important. Now we want to figure out how many times is the base used as a factor. In other words, how many times is negative 2 multiplied by itself? And it's 1, 2, 3, 4, 5. And so your exponent is 5. Now, sometimes we write it with parentheses, negative 2, 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 parentheses, which we all know means multiply. So you can see it either way, but there's still going to be the answer that is written here in exponential form in parentheses. Now, you might ask yourself, why? Why do we have to put the parentheses on? Well, I'm going to tell you why. If you had written it this way, negative 2 raised to the power of 5, that does not mean negative 2 times negative 2 times negative 2 times negative 2 times negative 2. What it means is, it means negative 1 times positive 2 times positive 2 times positive 2 times positive 2 times positive 2. Because the negative is not in parentheses, the negative is not part of the base. So the base for that exponent of 5 is positive 2. And this is one of the the two most trickiest things of what I'm doing right here on this slide. So please make sure you know how to do this, okay? All right, let's go ahead and start simplifying expressions. Here we got 8 raised to the power of 3. Again, you want to ask yourself first, hey, oh, well, their directions are to write in standard form, okay? So you want to ask yourself, hey, what's the base? Well, the base is 8. How many times is 8 used as a factor? 3 times. So 8 raised to the power of 3 is 8 times 8 times 8. And then you would simplify because you want it in standard form. And so that'll be 512. Now I'm going to go ahead and erase the directions so we can do some more problems on this side. Here we have negative 5 raised to the power of 2. You want to ask yourself, what's the base? Well, because the negative is in the parentheses, the base is negative. So the base is negative 5. And again, you don't want to write it this way. You want to write it as negative 5 times negative 5 because the base is used as a factor 2 times. You can also write it with parentheses. Those mean the same thing. I like to put them in parentheses all the time just to remind me that the base is negative. And then you simplify negative 5 times negative 5. Well, negative times a negative is a positive. 5 times 5 is 25. And so that simplifies to positive 25. Okay, last type of problem you're responsible for is when you have negative 3 raised to the power of 2, or negative 3 squared here. Again, this is going to be one of the tricky ones. You want to ask yourself, what is the base? Well, if you recall, I told you earlier that the base is not, if the negative is not in the parentheses, it's not part of the base. So negative 3 squared means the base is 3. And how many times is 3 used as a factor? 2 times. But because there's a negative, it means negative 1 times positive 3 times positive 3. Okay, again, the base is positive 3. The negative is not part of the base because it's not in parentheses. And so then you're going to simplify. 3 times 3 is 9. Negative 1 times 9 is negative 9. So these are the 3 types of problems you guys are going to see. Please make sure you learn them. All right. Here we have exponents of 0. 6 raised to the power of 0. Well, again, in my class, I want you guys to identify the base. What is the base? 6. How many times is used as a factor, excuse me? And because the exponent is 0, it's used 0 times. And so what are you going to do? Well, remember, 6 is the same as 6 times 1. There's an infinite number of 1s. 1 is called the invisible factor because you can multiply anything by 1. But because you have an exponent of 0, there is no factors of 6. So really, you end up with 1 times 1 times 1. So any number raised to the power 0 is equal to 1. Okay, very, very, very important. X raised to the power does not equal 0. A lot of kids say it is equal to 0, but it is not. Okay, let's try another one. Here we have 11 raised to the power 0. Again, what's the base? Well, the base is 11. How many times do you use the factor? Well, 0 times, so cross it out. But you need to write down the invisible factor. So 11 raised to the power 0 is 1. Okay, now you don't have to write down the 11, but I like to write it down because, you know me, I'm Mr. Lemus, and that's the Lemus way. All right, let's try another one. Here we have negative 2 raised to the power 0. Now, what's the base? Well, the base is negative 12. I'm sorry, I said 2, but it's negative 12. Now, because the base is negative, you have to put it in parentheses. The way I wrote it down earlier was not correct. And so since the base is negative 12, how many times is negative 12 used as a factor? Well, 0 times. So you cross it out. But what is the invisible factor? The invisible factor is 1. And so the general rule, anything raised to the power 0 is going to equal positive 1. All right, let's take a look at some more type of problems. Now we're going to do negative exponents, okay? Now here we have 6 raised to the power of negative 2. Once again, you need to identify the base. What is the base? The base is 6. How many times do you use a factor? Well, ignore the sign up there for now. It is used negative 2 times as a factor, but it is used as a factor 2 times. So it's going to be 6 times 6. But because there's a negative, what happens is the factors are not going to go on the numerator. They're going to go on the denominator. And so you end up with 1 divided by 6 times 6 because the base is positive 6 and the exponent is negative 2. And the negative exponent tells you that your factors are going to go in the denominator. Okay, let's try another type of problem you're going to see. Oh, by the way, sometimes teachers tell you guys to write it as a positive. You just simplify it, write it as a positive, as 6 squared in the denominator and 1 in the numerator. Now, I did forget to mention that negative exponents are not allowed. They are not simplified. So negative exponents are against the law, like I tell my students. Negative exponents are against the law. So you have to simplify them and write them with positive exponents. All right, let's take a look at the next type of problem you're going to see. Here you got 5 raised to the power of negative 1. Again, what's the base? Positive 5. How many times is used a factor? 1 time. But whenever the exponent is 1, we don't write the exponent. So we just leave it as 5. Now, because the exponent is negative, it's going to go on the denominator. And so you end up with 1/5. All right, it's going to take a while for you guys to get in the groove with this, but you're going to have a lot of practice. All right, let's take a look at this problem. Negative 5 raised to the power of negative 3. Again, when you do these problems, what is the base? The base is negative 5. But because the base is negative, it has to go in parentheses. How many times is the base used as a factor? 3 times. So it's negative 5 times negative times negative 5. But because the exponent is negative, your factors are going to go in the denominator. And so you end up with 1 divided by negative 5 times negative 5 times negative 5. Your numerator simplifies the 1. Negative times a negative times a negative is negative. 5 times 5 times 5 is 125. And so you end up with 1 divided by negative 1/25 or negative 1 125. All right. And the next problem that you're going to see in my class. Here we have negative 3 raised to the power of negative 4. Again, you need to identify the base. What's the base? Negative 3, and automatically put in parentheses because my base is negative. How many times use the factor? 4 times. But because the base is negative, it's going to go on the denominator. I'm sorry, because the exponent is negative, excuse me. Because the exponent is negative, your factors are going to go on the denominator. My apologies. And then you simplify your numerator 1. Your denominator is negative times a negative times a negative. It's going to be positive. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. And so you end up with positive 1/81. The negative exponent tells you that the factors are going to go in the denominator. It has nothing to do with whether your answer is going to be positive or negative. And you can see by these 4 examples, there is a pattern, which I will tell you later. Okay, I do want to point out that, again, some teachers make you write it as a positive exponent. All right, and that's the blue problem. And then the other problem, negative 3 raised to the power of negative 4. Some people write it 1 divided by negative 3 raised to the power of 4. And you need to know how to do that. All right, that's my quick little tutorial on integer exponents, which should be really integer powers. You guys have any questions, let me know.